Hello everyone, in this video we're going to do an introduction to special right-angled triangles. Now when you have one angle and one side in a right triangle, you can use sine, cosine, or tangent to find the missing side, one of these. But there's another way to figure that out, and they're with special right triangles. Your special right triangles are 30, 60, 90 triangles, or 45, 45, 90 triangles, where 30, 60, 90, and 45 refer to the angle measurement. Those are the degrees. Okay, let's look at the triangle over here. Let's make this angle 30 degrees. And then let's make this one 60 degrees. The angle opposite 30 degrees will always be x, okay? If the triangle is set up like this, the angle opposite 30 will always be x. The angle opposite 60 degrees will always be x times the square root of 3. And then the angle opposite the right angle will be 2x. So also the hypotenuse. Now let's look at this one. Let's look at this triangle. This will be our 45, 45, 90 triangle. The angle opposite the angle opposite the 90 degree angle will always be x. Or sorry, x times the square root of 2. And then the angle opposite the 245 degrees will be just x, okay? These are diagrams that will be very important in trigonometry and your geometry life, okay? Let's look at some examples. If I have a 30, 60, 90 right triangle here, and then I make this side x, or no, we make it 2. Well, if we look back at our diagram right here, x is equal to 2. So now we just have to plug in those numbers for the other two sides, the hypotenuse and the 60 degree side. So we have 2 times the square root of 3 for the side opposite 60. We like to, this is in its exact form. If you'd like to use a calculator, you can do so. But we have 2 times the square root of 3 for our angle opposite the 60 degrees, or for our side opposite the 60 degrees. And then we know this side will be 2x, but x is 2, so we need 2 of those. So 2 times 2 equals 4, so this side will be 4. Now you know lots of good stuff about that triangle right there. Okay. Let's get rid of this. Now let's look at an example with 45, 45 triangles. 45, 45, 90 triangles. Let's say that this side is 5, and these two angles measure 45 degrees. What is x and what is y? What are these two sides right here, x and y? Well, if we look back at our diagram, the side opposite 45 degrees will always be just 5, okay? So that means the side opposite the other 45 degree angle will be also be 5. So x in this diagram is 5. And then we have 5 times the square root of 2, because it's x times the square root of 2, and x is 5. So y equals 5 square root 2. Okay. Let's look at some more problems. What if this was a 30, 60, 90 triangle, and I had 6 right here? 6 is opposite the 60-degree angle. What are the other two sides? Well, since this is opposite the 60-degree angle, we know that x root 3 has to be equal to 6, because the side opposite the 60-degree angle will always be x times the square root of 3. Okay? So now we have to solve for x here. As you should know, we should divide both sides by the square root of 3. X equals 6 over the square root of 3. Now, in geometry, and in any algebra for that matter, we like to not have square roots inside of the denominator. It is okay if we have them in the numerator, though. So we're going to multiply top and bottom by the square root of 3. Two square roots with the same number in them cancel. Okay. So we just have 6 square root 3 over 3 equals x. But we can simplify this even more. How many times does 3 go into 6? It's 2. So 2 root 3 is equal to x. And if we refer to our diagram, the angle opposite 30 is always x. So that's going to be 2 root 3. Now, what about the hypotenuse? Well, x is 2, so what would 2x equal? How do we get 2x? What does 2x equal? So I noticed that if we multiply this equation by 2, we can get 2x equals 4 times the square root of 3. So we have 4 times the square root of 3. Sometimes when you do special right triangles, you will have to do stuff like this and rationalize the denominator, get the square root out of the denominator. Sometimes you don't have to do that. But I would refer to the diagram as much as possible. So let's get rid of all this. And then let's do a 45-45 example. Let's make this side 9. What if it's 9? The hypotenuse is 9. Well, the angle, or the side opposite the 90-degree angle, will always be x times the square root of 2. So we know x times the square root of 2 is equal to 9. Now let's divide both sides by the square root of 2. So we get x equals 9 over the square root of 2. Now we can't have a square root in the denominator, so we have to multiply top and bottom by the square root of 2. Square root, you should know a square root times itself gets rid of that square root. So we have x equals 9. The square root of 2 is attached to the 9 over 2. And both of these angles are 45, or both of these sides are opposite 45-degree angles. So this should be, this side should be 9 times the square root of 2 over 2. And so should this side. I hope you found this video helpful. If you have any questions, please leave them in the comments. Thank you for showing up.